All right, so we're going to do some more integration today, but we're going to do use substitution, which is going to be the chain rule backwards. So let's first see if we remember the chain rule. If you have a derivative of x squared plus 1 to the third, let's think of how we would get that derivative. Well, hopefully you would remember that you would do the power to the front. You have a composition, so you do the derivative of the outer, which is power to the front, and you would decrease the power by 1. However, you would not stop there. You would say, well, I would need to multiply by this inner derivative, which is a 2x. And I know I can clean that up, but that's not the point. I just want you to remember the chain rule. We also have to remember it with trig as well, in that if I say, what's the derivative of the cosine of 5x, you don't just say negative sine of 5x. You have to do what? You have to put that derivative of the inner function, which is 5x, and you would have to put that in front. So with integration, if there's a chain rule for derivatives, then there's probably a chain rule-esque for the integration as well. So let's look at it. So if I wanted you to integrate x plus 2 to the fourth, can we do that? Does just straight power rule work? Will that be increase the power by 1 and divide by the new power? I could put that over 5 or put 1/5 plus c. Does that work? Yes. Why? Why is that one? Do I not have to think about use substitution? I could, but I'm making it harder on myself. Why does the power rule work for that? Well, it's because if you look at this inner function, what is the inner derivative of that? The inner derivative of that is 1. So straight power rule is going to work. However, if I change that ever so slightly to be 5x plus 2, you must use substitution. In other words, if you think that this is equal to, oh, increase the power by 1 and divide by the new power and say this is the answer, that is not going to be correct. Okay, you have to use substitution since the derivative of the inner function does not equal 1, or is not 1. I'll say it that way. If the inner derivative is 1, straight power rule will work. So I want you to recognize when you have to use u sub versus you can do it the fast way, because timing is a big deal. So what are the steps for u substitution? Well, here they are. You're going to choose your expression for u. You're going to take the derivative of u and solve for du, make a substitution. You should get to a simple integration. You're going to integrate and substitute back in for u. Okay, that sounds like a lot of steps, but we will go through the steps as we work. Now, for the point of today, it's like, okay, choose your expression for u. That's the hardest part. And so for right now, one good choice for you is when you see a power. Now I'm saying, is every problem going to be done this way? No. But if I see a function raised to a power, your choice of one good choice for you is whatever is being I'm trying to talk and write at the same time. Whatever is being raised to that power. So one good choice for you is what is raised to a power. Here's what I mean by this. Okay. And I purposely have these examples 1 and 2 right next to each other to show you a difference of what you need to be looking for as you go. So let's check it out. When I see example 1, I first of all realize, okay, I've got to do use substitution because what's being raised to the power, I see a power of 6. What is being raised to the power certainly does not have an inner derivative as 1. So I think, okay, I probably have to do u sub. And for right now, it says one good choice of u is what is being raised to the power. So I'll just say that u is equal to x to the fourth minus 5. So that is step 1. Step 2 says take the derivative of u and solve for du. Here's what I mean. Now you're going to do this in one step. If I said take du dx, the derivative of u with respect to x, you would say 4x cubed. Now when I say solve for du, you have to see these two things as being separate. We've always kind of looked at it as one thing, but they're two different things. So I'm just going to pop that dx to the other side. So normally, rather than writing du dx, I'm just going to say that du is equal to 4x cubed dx. That's actually called the differential du. And I'm just going to put the dx on that side. Now, what is the point of u sub? Well, the whole point of u sub is to substitute in u's for x's. Notice that all of these things are being multiplied together. So if things are being multiplied, I can write them in any order that I choose. So I'm going to choose, because of experience, because of doing these problems many, many times, I recognize, it's probably good if I write it like that. Now let's make the u substitution. I have the integral. What is all of this? Well, that's u. So I have u to the 6th. Now looky here. Look at all of this and look at what I have right here. I have all of that stuff. 4x cubed dx is du. So I'm just going to replace all of that with du. So do you see how I have everything in terms of u? And like it says you should get to a simple integration. If you're not getting down to a simple integration, you might have substituted incorrectly. But you know how to integrate something u to the 6th. You'd go, well, that's a piece of cake. 1/7 u to the 7th plus c. Now that's not my final answer. My last thing is substitute back in for u so that the final answer is in terms of x. So my final answer would be 1/7. U was x to the 4th minus 5 to the 7th plus c. And that is my final answer right here. Okay? Now let's look at example 2. And I want you to see the difference in example 2 and example 1, because example 2 is a little more involved. Let's check this one out. Okay, I have x times the square root of that, and you know that I could write that as x times 2x minus 1 to the 1/2. So I do have something to a power, and because I don't know anything else to do, I will let u be 2x minus 1, because that's the thing being raised to the power, so that's really all I know what to do. Now what is du? Well, du is the derivative of this thing with respect to x, which is 2, but don't forget to put the dx on there. So I have that. Okay. Now, like we did before, I'm going to scoop this over so I have a lot of room. I'm going to kind of write in this particular order just because I tend to like it that way. I have to do u sub. So this first one is pretty easy. 2x minus 1 is u. So I could integrate u to the 1/2. Since 2x minus 1, I'm looking at this statement right here, that is u. Okay, well, the dx, I've got to substitute the dx as well, which I could do that one pretty easily with this guy. I could solve and say that du over 2 is equal to dx. So in for this dx, I could put du over 2. But I also have this x right here. Well, how do I get that in terms of u? Looking at these two statements, is there a way that you could solve for x? And you go, yeah, I could. Using this top line, I could bring the 1 over, and that would be equal to 2x. So I would divide by 2, and this would be equal to x, and that's what I'm going to put right here. Now this doesn't look that much better because you guys still have a product, but here's the difference. You can simplify this product. So let me do that. One of the biggest mistakes is the number that you bring out. Notice these are fractions. When you multiply fractions, you remember you multiply straight across the top and bottom. So 2 times 2, do you see that I really have a denominator of 4? So I'm going to go ahead and pull that 1/4 all the way out just to get it out of the way. And if I did that, I would have u to the 1/2. I'm doing this in steps. You could probably combine a couple of these steps. I would have this. Now, why is that better for me? Because I can now distribute. These are both, this is to the power of 1. So I'm able to distribute this in. I would have 1/4. Remember, when you multiply things with exponents, you add. So a 1/2 plus a 1 is 3/2. And then u to the 1/2 du. And now I can integrate those things with power rule. I'm just going to go down the line. If I integrate with power rule, I would have u to the 5/2, if you add 1, so plus 2 over 2, that'd be 5/2. Divide by the new power would be 2/5, plus u to the 3/2, I would have 2/3, and then plus c. And then in the last step, I usually combine a couple of steps. I'm going to distribute that 1/4, which again, you don't technically have to. I mean, you could write it. I just kind of like to. And then I'm also going to substitute back in my u. Remember that u is 2x plus 1. So if I distribute the 1/4, I'd have 2 over 20, or 1/10. U was 2x minus 1 to the 5/2. I'm also going to distribute the 1/4 here. That's 2 over 12, which is 1/6. And I would have 2x minus 1 to the 3/2 plus c. And this, my friends, is my final answer. A lot of work to it, but I can get there. So I wanted you to see kind of two different things, because sometimes the du substitutes really easily with the x, and it kind of becomes real simple. Sometimes it does not. So you have to kind of make sure that you're looking at both of those. So let's keep looking. Let's keep on rocking. Let's see if I can get to the next slide. Here we go. All right. So this one, I know it's like, wait, there's trig in there. I mean, but I still have something to a power. So let's keep working this the same way. So let's keep checking out. What do you think I'm going to use for u? Well, this is really sine of 3x to the 5th. So I do have something raised to a power. So I'm going to, because I don't know to do anything else, I don't know, I put a parentheses there, but I'll let u be sine of 3x. So what would the derivative be? du. Now here's where a big mistake happens. People put cosine of 3x dx. What's wrong with that? Well, I've got to remember chain rule when I'm taking derivatives. The derivative of sine of 3x is 3 cosine 3x dx. Now let me do my substituting. Here we go. I have the integral. This is u. I have u to the 5th. Friends, look at all of this. Cosine of 3x dx. Do you see that's what I have right here, cosine of 3x dx. So what can I replace all of that with? Wouldn't all of that be du over 3 if I solved? Now, here's what I do. Now that you've seen it, I'm trying to kind of make the steps a little bit shorter for you. I tend to put my du here, and I put the 1/3 on the outside. I just like to do that. Okay, and hopefully you can follow where I got that. This cosine of 3x dx, which is what I have here, and I've got to substitute for that, is du over this 3. So I put the du next to u, and I put the 1/3 on the outside. The integration is simple. U to the 6 times 1/6, don't forget about the 1/3, plus c, and then I just clean it up and resubstitute. So I have 1/18. My u is sine of 3x, and I'll write it mathematically how I think they would type it, plus c, and I'm done. Good, good, good. I'll put a little parentheses around there. That's probably good. Cool. I want you to try example 4 all on your own. Okay, so stop the video and try that one. Come back when you're done. We're going to let u be 7x plus 2. du is 7 dx. So what do I have when I substitute? This is u. I have u to the 9th. Now what is dx? Friends, if I solve for dx, dx is du over 7. I like to put the du here. I like to put the over 7 there. Integrate, u to the 10th, 1/10 times 1/7 plus c. My final answer, 1/70th. U is 7x plus 2 to the 10th plus c. And there's my answer. So it sounds hard, but the steps, you just kind of follow the same steps, and you can rock on through. All right, why don't you try 5 and 6 by yourself? So again, stop the video and try 5 and 6. Now 5, I was kind of mean on 5 because 5 is not a u substitution problem. But I threw it in there because I wanted you to recognize when you're going to use u sub and when you don't. Remember, if you have a quotient and this bottom is a monomial, a single term, I would just divide. So remembering my exponent rules, that's really 1/2. Remember when you divide exponents, you subtract? So really, what am I integrating? If both of these things get divided by x to the 1/2, yes? So when I divide, I subtract exponents. What is 1 minus 1/2? That's 1/2. And then 2x squared over x to the 1/2. What is 2 minus 1/2? Is 2x to the 3/2. This isn't a u substitution problem at all. If it's a monomial, just divide it out and then do the integration. So x to the 3/2, 2/3, plus that'd be x to the 5/2 times 2/5 would be 4/5 plus c, and that problem is done. Not u sub at all. Tricky, tricky. All right, example 6. Here we go. Well, oh boy, okay. I see a really wackadoodle thing to a power. So let's put all of that. And I'm going to rewrite this because I know I can't have a quotient. So I'm going to write this as that to the, if I'm bringing it to the top, negative 1/3, because I'm moving it to the top. And then I have x plus 1 dx. That's my problem, correct? Well, let's do du. du is 4x plus 4 dx. Okay. Now let me give you a second to stare at that for a minute. Because when you substitute, well, this one's easy, u to the negative 1/3. Now I've got to substitute for x plus 1, and I've got to substitute for dx. You look for ways to make that easy. You look at your du. Do you see it? Let me do this. If I wrote du as 4x plus 1, what if I wrote it that way? Isn't that the same thing? And you go, oh heavens. Look, x plus 1 dx. This is what I have to substitute for, x plus 1 dx. What would that be equal to? Well, that's going to be equal to du over 4. Well, golly darn. Du over 4. Piece o' cake. Integrate u to the negative 1/3. Increase the power by 1, should be to the 2/3. Divide by the new power, or multiply by the reciprocal, plus c. Now substitute back. Again, that's 3 over 8. I want that to be in pink. 3 over 8. My u was that long old thing. Plus 5 to the 2/3 plus c. Boom shakalaka, you are done. Okay? We got one more u sub. So here's what I want. I want you to see if you can decide what you're going to put for u and do the substituting. Okay? So again, the more you practice, the better. So stop the video and try yourself. You're going to let u be 4x plus 3. You're going to let du, just take the derivative of this, is 4 dx. Now I'm going to start my substituting. So let's see here. Well, okay, I mean, I won't rewrite this one, but I'll substitute for what's easy. I'm going to leave some space for the x squared because that one's a little weird. But this one is pretty simple. 4x plus 3, the square root of that, that's really like u to the 1/2. Okay, so that one I get. Now dx is pretty easy to solve for because of this line right here. Do you agree that dx would be du over 4? Now I'm going to go ahead and write this one like this. Yeah, yes, you could bring the 1/4 out, and I'm going to do that, but I'm going to wait till I substitute for everything. But do you see how in this problem I'm not able to solve? You always look at your du step. If you have x's here that match up with these, then you want to do it all in one substitution. But the problem is I don't have one. I don't have an x in my du. So what I'm going to have to do is right here, I'm going to have to solve for x. That would be u minus 3 over 4, and that is equal to x. So what I have to put in is u minus 3 over 4. Now be careful, that is parentheses squared. That's kind of the key step there, is getting the correct substitution. Now this next step is oftentimes missed as well. Let me get all my numbers out of the way. What number would I pull out? I want you to think of that. And my guess is I'm going to hear one of 3 numbers: 4, 16, or 64. Now, which one is right? Notice if I were to square all this out, I have to do, and I'm going to write it out, I would have to do u minus 3 squared, u to the 1/2 du. Would you agree that that denominator 4 would also get squared? Because when you square a fraction, you square the top and the bottom. So this one gives me a 16. I also have to multiply by that 4. So those of you that thought the number that I pull out is 64, you are correct. Now I'm not really ready to integrate yet, because I still can't distribute this through until I square. So I would have u squared minus 6u plus 9, and then I'm going to have u to the 1/2 du. Now I'm ready to distribute that u to the 1/2. So that would be u to the 5/2 minus 6u to the 3/2 plus 9u to the 1/2 du. Now I have to integrate. 1 over 64. Let me integrate u to the 7/2 times 2/7. Correct? Minus u to the 5/2. Now remember, you have 2/5. Here, I don't want to confuse you. You have 6 times 2/5. I'll clean that up in a minute. So that'd be 12 over 5. Just making sure you get where I'm getting my numbers. And then I would have u to the 3/2 times 2 over 3 times 9, all of that plus 6. Now watch how I'm going to write my final answer, because remember, now granted, if it's multiple choice, would they distribute that 64? Probably. Okay, they're going to write the answer in the most simplified terms, but I'm going to pretend this is on free response. Y'all, they don't care if you, they will accept any answer that is correct. So I'm going to choose not to distribute that 64. I'm going to leave it, and you would get full credit. What was my u? 4x plus 3? You would get full credit for this answer right here. Now I'll choose to do 12 over 5. That one's not too shabby at all. But I would have minus 12/5, 4x plus 3 to the 5/2. And that's a pretty easy, that'd be what, plus 6? I could do that, not so bad. They would give you credit if you didn't simplify those numbers even in there, but if I feel pretty confident in my head, I'll do them. But that 1 over 64 and they're big numbers and I have to multiply by, I don't want to do that. So this, be smart in how you write your answer on free response. Yeah, if that number on the outside was a 4 and I could simplify easily, I usually do, but I'd get credit if I didn't on free response. So be really smart in how you answer questions if it is on multiple choice or free response, because I would not distribute. So that's U sub. So that's what I want you to practice tonight. Go through those steps and see how you do. All right, friends. Peace out.